Hi guys, welcome to this set of videos. What we're going to do here in these videos is we're going to follow along with the notes that come out of your guys' textbook from Chapter 3, Section 8. Now in Chapter 3, Section 8, what we're going to do is we're going to look at another method for solving systems of linear equations using matrices. Now specifically, the new process we're going to learn for solving systems of equations is known as a matrix equation. We're going to solve a matrix equation, and by doing that, it'll help us solve a system of equations. But before we can solve a matrix equation, we also need to talk about a couple other things when it comes to matrices, and that would be the identity matrix and an inverse matrix. So actually, the title of the section is Identity, Inverse Matrices, and Matrix Equations. Now, before we can write matrix equations, we do need to talk about the identity matrix and inverse matrices. So let me get you a couple of objectives or learning targets to get us started, and we'll jump right into this. By the end of this set of notes, you guys should be able to find the inverse of a 2 by 2 matrix. And finally, you should be able to write and solve a matrix equation that will allow you to solve a system of equations. So here we go, let's jump right into this. Quickly review a little bit of algebra with you from real numbers, and this is what we want to recall. The identity property of multiplication. And here's what it says. Pick any number n, right? Pick your favorite number, doesn't matter what number it is, positive or negative. It could be rational or irrational, right? Doesn't matter. Pick any real number, and if you multiply that real number by 1, you get back your real number, right? So anything times 1 is itself, right? The identity property of multiplication. Well, it turns out we have an identity property for matrices as well. What we can do is multiply any matrix by this identity matrix, and we get back the original matrix. It's just like multiplying a number by 1. You get back the original number. We can do the exact same thing with matrices. Now, here's the identity matrix. They only exist for square matrices, and these are them right here. There is a 2 by 2 identity matrix, a 3 by 3 identity matrix, 4 by 4, 5 by 5, 6 by 6. You could go as big as you wanted to. We will only ever use the 2 by 2. When it comes to solving systems of equations using matrix equations, guys, we're only going to do systems of 2 equations. The systems of 3 is way too complicated for what we're going to do in this class. So this is as big as you need to go, the 2 by 2, but I just want you to know the other ones exist, and here's how they work. In order to write an identity matrix, the major diagonal is going to be 1s, right? Every other element in the matrix will be 0s, right? So I have a 1 and a 1 on the major diagonal. My other 2 elements are 0s. This is the identity matrix for 2 by 2. 3 by 3 identity matrix, my major diagonal are all 1s. All of the other elements are 0s, right? If you had a 4 by 4, right? All the major diagonal would be 1s. Everybody else would be 0s, right? They're just that easy to make. And here's what they do. Remember, what we said is if you multiply any number, pick any real number, you multiply it by 1, you get back that original real number. Well, the same thing happens with matrices, right? If I take a matrix A and I multiply it by the identity matrix, or the other way around, multiply the identity matrix by some matrix A, what I get back was my original matrix. And I show that to you right here, okay? So I take the matrix A, B, C, D, and I multiply it by the identity 2 by 2 matrix, the 2 by 2 identity matrix. Or flip it if you want, because a multiplication is going to be commutative in this case. Any identity matrix multiplied by some matrix, you get to pick what you want the matrix to be, A, B, C, D, I get back the original matrix. Now I mentioned before that multiplication is not commutative for matrix multiplication, right? There is no commutative property for matrix multiplication. In this case there is, and the reason is because we're multiplying by this identity matrix, and I'm always going to get back the original matrix. So let's go ahead and do an example problem together just to show you how this works. Plus, this will be really good review of how we do multiplication. So, here we go. I'm going to take the matrix 3, 2, -1, and 5, and I'm going to multiply that by the identity matrix, which for 2 by 2 is going to be 1, 0, 0, 1. Remember, identity matrix, the major diagonal, all the elements are 1. Everybody else is going to be a 0. All right, now let's refresh on how multiplication works, right? Here's how it goes. Remember, I take the first row, first column, multiply corresponding elements, and then add them together. So 3 times 1 is 3. -1 times 0 is 0. 3 plus 0 is 3. Take row 1, now column 2. 3 times 0 is 0. -1 times 1 is a -1, and 0 plus a -1 is -1. Well, so far we're off to a really good start, right? I got a 3 and a -1 in my original matrix, and right now my product matrix has a 3 and a -1. Let's keep going to make sure the rest of it works out. I've now done row 1 and both columns, so now we switch rows. Row 2, column 1, again, sorry, that should be a 5. Okay. 2 times 1 is 2. 5 times 0 is 0, and 2 plus 0 is 2. Row 2, column 2, so 2 times 0 is 0. 5 times 1 is 5, and 0 plus 5 is 5. And so what we have now just seen is that actually multiplying any matrix by the identity matrix, you get the original matrix back, the identity property of matrices. Guys, thanks so much for joining me for this page of the notes. Head on over to the next page of the notes and we'll find another interesting property of matrices. I'll meet you over there.